Hello. Few more people might be joining. So, hello, am I audible? Hello.
Yes, sir.
Yeah. Okay. So, few more people might be joining. So, let's wait for a couple of minutes. Then we'll start the session. All right. So, let's start. So the numbers are low, but yeah, we can start. Uh, Hello, everyone. Good evening. My name is Omkar Joshi. I'm course instructor for computational thinking. And I will be conducting today's session, which is Solve with Us for week 11. Uh, so I hope you all know the drill. You're supposed to join peer deck and supposed to solve the questions and submit answers from there. And post your submission, we can discuss the question, and if you have any doubts based on that particular question, we can discuss those immediately right there. All right. So let's start. I am seeing some discussion in chat over here. So yes, syllabus for end term is all 12 weeks, 1 to 11 or 1 to 12, whatever you consider, because 12 is just a summary, but it's all 12 weeks of content is the syllabus for end term. Okay, and weightage, we do not announce any specific weightage. There will be a question based on all the topics which we have studied, right? The basic programming constructs which we have studied in first 4 weeks, followed by list, dictionary, and graph, right? Majorly, those are the components which we have studied, right? The basic constructs which you studied in first 4 weeks. Then week 5, 6 is list, 7, 8 is list, is dictionary. Then 3 weeks of graph plus recursion, right? So that's the basic syllabus, and so we do not announce any specific weightage or distribution of marks. It's just 100 marks paper, 1.5 hour of time on 11th of December. That's the thing. Beyond that, mock exam will be there in most probably in upcoming week. So yeah, you can solve that. Yes, Kajari, quick question. Then we'll start
I'm
with
asking something with not from this course. I'm just asking about the event which is going on, which will be happen on 2nd Jan. So can I
yeah.
ask something?
I'm not honestly, I'm not fully aware of that event. You
Okay.
better write to student affairs head Kotai.
Sir, you said
Okay.
about the examination being 100 marks, no?
Yeah, 100 marks paper for 1.5 hour.
Okay, sir.
Yeah.
So means it will be more duration one.
Yeah, 1.5 hour, right? Usually your quizzes is 45 to 1 hour, 45 minutes to 1 hour, right?
Yeah, yeah.
And that paper is usually 50 marks.
Okay.
100 marks for double time. So it's in
So
that
that means the
proportion.
question will also be double, right?
I'm not say exactly double. There might be less, there might be more. I mean, see, the amount of time required to solve those questions will be 1.5
Okay,
hour.
so
Yeah.
got it, got it.
I mean,
And the
I mean,
that
there might be some questions, right, which you can solve maybe in 10-15 seconds. So if you
okay,
consider those, then maybe number of questions might increase. So don't
okay.
worry about number of questions. The time is 1.5 hour, and we will make sure that it's sufficient for the
I am
given.
asking because means I lack a lot because
Mhm.
due to this quiz 2, I was busy preparing with the quiz 2, and
Okay,
my quiz 2 went well, no issue with that. But
right.
now I am lacking behind, so I'm just covering up things. So I
See,
hope that
Purnendu, if you have done well in quiz 2, that means you are all set till week 8, right?
yeah,
So that means list and dictionaries are covered. Only concept
yes.
now remaining is graph and recursion.
That matrices also, sir. That was
I
not
mean,
there
yeah, I
in the
mean,
quiz
matrices is nothing but a representation of graph
of
only.
graph. Yes,
Yeah. So, I mean, the
I find
basic
it little
concept.
bit hard. That's why I asked.
Yeah, I mean, of course, it will be. That's why we spent 3 weeks on same concept, right?
Okay,
For very same reason. And there will be revision sessions for all this. So,
okay,
I
sir.
mean, of course, you can watch lectures, and that standard procedure is there. On top of that, these sessions will also help you,
Yes, sir.
right? So,
Because this week 11, right? It's for week 11. Today for week
yes,
11,
today is
right?
for week 11, right?
Yeah, and I haven't means watched any lecture of that because I'm busy with week 10, but I will try to solve here also.
Okay. Now that might not be a good idea, but okay.
It's
Try to
try.
do it. Yeah, sure.
Problem. I am with.
Hello.
Yes, sir. I am from same category.
Okay. Yeah, I mean, let's try to solve. I mean, I will be also explaining on the way. I mean, not while you're solving, but post. I mean, after giving you some time and so on, I will be solving those. I will try to explain so that.
But math I have done, sir. That will be helpful. I think so.
May not be because graph theory concept what we have studied in maths is different.
No, no.
That's
BFS,
that's
GFS concept was
purely,
also there.
yeah, concept is there, but pseudocode will not be there, right? In math,
Yes, sir.
pseudocode is not there, but here it's
Searching
not
algorithm we
pseudocode.
have there. Learn Prisma.
Yeah. Okay, so let's start. We'll see how it goes. Okay, so if you struggle, just let me know with some question. Maybe I'll explain you at that point. Okay. So I'm sharing my screen.
Okay,
This is
sir.
the ID for this one for joining the slides. I'm just posting the link also directly in the chat. You can directly click on that link and join the peer deck. In that case, you will not require this ID and nothing of that nature. Simply click on the link shared in the chat and you're good to go. So only one student has joined so far. What about others?
Just opening, sir.
Okay.
Network issue, sir. It is opening, sir.
Okay. So 6 are there. Others quickly joined so that we can proceed to our first question. If you're facing any issue in joining, please let me know so that we can figure out if there is some problem. Because only 8 people are there, just half of what we have in Zoom. Anyone is facing any issue, please let me know. Okay. Okay. So yeah, fine. Some 10 people are here plus me. So let's start. So this is week 11 computational thinking. Solve with us. And
And sir, week 12 is also there for CT, or it is not just like mathematics.
sorry. Yeah, Ritik,
Actually,
can you repeat?
mathematics had only up to week 11 concept, and week 12 is only revision. Is it also with CT, or there is
Yeah. So
concept in
it's
week
same.
12?
It's same. Week 12, you have only summary of the course. There is no new content, but it's better you watch week 12 content because it will be very helpful with respect to your preparation. Because we have prepared some tutorials for week 12, which will be really helpful in order to revise all 11 weeks.
Yes,
Okay.
so that will be great
Yeah.
for us.
So in a short period of time, you can revise the content. Okay. So week 12 is not yet released, huh? Is it released or not?
Yes, sir. It's released
It's released,
today.
right? Yeah.
Yeah,
Okay.
it's released today.
Okay.
Actually,
Fine.
yesterday it was not released.
Yeah. So today it's released as somebody else pointed, right? So maybe you can
Yes.
go and look at it. Okay, so let's start with question 1. And just a disclaimer at the beginning, right? Don't worry about the number of slides. They may look big number 123, but I mean, you will know why the numbers is huge. We will be able to manage sessions within 2 hours. Okay, so don't get scared of number of slides. Okay. So sometimes that's the tendency of students, right? Oh my God, 123 slides and so on. So I'm just telling you in advance. Don't worry about that. So this is the first question. Let me read it out and then you guys can start solving. Already, I guess somebody have submitted one response, but anyways, yeah. So given a list of integers sorted in ascending order, write a recursive procedure that returns the list sorted in decreasing order. Okay. So you can assume that this L, right, the input to this particular procedure L is a list in sorted order, consisting of integers, and it is in sorted order. Okay. And what you are supposed to do is you are supposed to return a string, which is in a decrementing order, right, in a decreasing order. So you are supposed to write that return statement right here, which will replace this line field code here. So the base condition is given, only recursive line is you are supposed to write. So I'll give you just maybe another 2 to 3 minutes to submit the responses. I'm seeing already 4 or 5 students have submitted. So Sam, if you're not able to see that week 12 drop down list, right, just refresh the page. Just do a hard refresh, Control Shift R. Okay, instead of regular refresh, just do this Control Shift R. It's called hard refresh, and that should solve your problem. Okay, I have some 8 responses. Another 5, 6 are remaining.
Done, sir.
Okay, so I'm seeing 10 people have submitted the response. So, all right. So let me see what the responses are, and then we'll look at the correct answer. We'll try to solve it step by step. Okay, so the responses are like this. Majority of people are saying last of C plus plus calling of that procedure with init of list. Okay, so it's 8-3. Let's see what's the correct answer. Okay, there is a small difference if you observe, right, between option B and D.
Yes, sir.
Yes, sir.
Yes.
I did D.
Yeah, so whoever have done D, can you observe the difference? I mean, we'll check, we'll
Yes.
see which is the correct answer and which is wrong. But please
Yeah,
note
because
that there is
last
a
cell is
very
not a list. Last cell is a
Yes.
single number.
correct. There is a very subtle difference
operand
between
must
option
be
B
list.
and D. It is the list part over here. This is in a square bracket, the last of L, whereas here last of L is integer as it is.
Yes.
So what about this one? Is it correct? I mean, I'm not saying this one is correct, but first of all, do you think this is correct?
No,
Uh,
sir.
So this plus plus operator must have operand as a list.
Correct. I mean, irrespective of what the question is, this is syntactically incorrect, right? Because plus operator always should have lists as operands, right? This is a list for sure. This one is also supposed to be a list. So
Okay.
this will create a problem, right? Because you cannot
Yes.
append something to integer. Right, you can append only two lists. That's what plus operator do, right? It merges or appends two lists. Currently what you have is integer, and you cannot operate with integer using plus operator. So syntactically this is wrong. Then now we'll see whether option B or C is correct, and then and so on. But okay, let's look at the explanation. So let's assume that this is our, for explanation purpose, let's consider this example, and we'll try to see what we are supposed to do. So this is what the original list will look like if there are 5 elements. And what we are supposed to do is remove the last one and insert at the beginning, right? That is what we are supposed to do. So take 5 out from last and put it at the beginning. Same thing will go with 4, same thing with 3, 2, 1, and so on, right? That's how we'll get that expected list which we are supposed to return. That's just a pictorial representation. Now let's see how to do this via pseudocode. Okay, so this is how to extract this 5. As most of you have figured it out, that's last of L. And you know how to get the remaining list, which is init, right? Init is a special function which gives us the list with all the elements except the last one. Correct?
Initial part.
Yeah.
Yes, sir.
Okay.
Initial part of the list except
Yes.
last.
Correct. Init stands for initial. The initial part of list excluding the last element. So that is how we got 5 separated out, and rest of the initial part of list is separated out. And what we are supposed to do is simply merge these together, right? So that the 5 will get added at the beginning, right? And how to merge them together using plus operator. That's something which we already know. So that's something we'll keep doing that. I mean, step by step, that's what will happen. So that 4, 3, 2, 1 will give us that in a recursive manner. So that's the answer. Anyway, I mean, almost everyone, all of you got that answer. So that is what we are returning here. Returning what? Last of L plus DESC, the procedure, and the updated parameter for that procedure is init of L. I think the only mistake those 3 people did is this: they missed this square bracket. Otherwise, your understanding was correct, and that's the correct answer, right?
Sir, I have a doubt in
Yes, tell me.
one. Yes,
Yeah.
sir. That one I have a little bit of confusing in. So first, if I concatenate the two lists, so my first
Uh-huh.
list is the list of list. So list inside a something list plus my second list is the singleton list. So if I concatenate
No.
together,
No, Ganesh, in this case, that's not happening, right? Last of L is the element.
sir, I'm not. I generally ask these questions.
Okay, you're talking about general. Okay, I thought with respect to this question. Okay, then
No.
Ganesh, just hold on. Let me close this question, and before starting the next one, I'll come to you. Okay.
Okay, sir.
Okay. So as
Sir, what
I
is
thought.
recursion, by the way?
Okay. When we okay. Okay. What is recursion is? Recursion is a special type of a function. It's a simple
Call by itself.
special type of a procedure which calls itself.
Okay.
So now this is a procedure, right? DSC.
Yes.
And in its function definition, this is called procedure body or procedure
Yeah,
definition.
I know.
It is calling itself.
Okay. Without even completing it.
Correct. Without completing it. That's called recursive procedure.
So means what should I take care while creating this recursive list?
Most
And what
importantly,
constraint
you
I can
should write
create
a
it?
code which will end at some point. The base condition is important. Otherwise, it becomes an infinite calling.
Okay, that if
This if
length L
condition.
is equal to less
Yeah,
than
and
1.
at some point, this calling should stop, right?
Yes.
Otherwise, you will call this DSC will call DSCLN. This DSC will call it again. So it again and again it will keep calling itself, right? It will never stop.
Yes.
So that way, this some condition has to be there which will stop this calling, and it will return something rather than
Okay, sir.
calling it again.
Got it.
That's why this base condition, this length is less than equal to 1, is very important over here, right?
Okay.
I mean, that will change depending on the requirement. Sometimes this condition might be different and so on. But that is the most crucial part of a recursive procedure. Okay. Yeah. That's something anyway we'll discuss. I mean, I'm planning to, I was going to announce this at the end of the session. But as we are on the topic, let me tell you, I'm going to conduct one live session dedicated for recursion. I understand many people face a lot of issues with recursion, and then because of that in DFS, because DFS algorithm uses recursion, right? So there will be a separate dedicated 2-hour session only on recursion and DFS.
Yes, sir. Thank
Yes,
you,
sir,
sir.
yes.
Because in
Okay.
pseudocode, the concept is we know, but when the pseudocode is coming on the screen, so we are getting confused how to.
Yeah. So
process.
I will conduct that session. It is scheduled on 2nd of December.
Okay, sir.
Okay,
Thank
2nd
you.
of December at 6 p.m. I am not sure whether it's updated in calendar yet or not, but it will be. Okay.
Thank you,
it
sir.
is updated. It's called
Thank you,
revision
sir.
session for week 11. So that's the session. Okay. So today we may not go into that depth. Today we'll focus and restrict our discussion to this these slides. And in that session, we will go in depth with respect to recursion and DFS and so on. All right.
Sir, that plus operator is same for appending list or they are different?
No, it's same. Plus operator is the operation is same. See, plus operator expect what? It expects two lists as operands, correct?
Yes, sir.
And it just you call it append, you call it merge, you call it insert, whatever name you want to give it.
Okay.
It took two lists and adds them together and gives you a resultant list.
Okay, sir. So
Right.
both are same.
Yeah.
Yes, sir. Got
Correct. So
Yeah.
okay. So let me finish this. Okay. So how this is happening recursively? I mean, people who had some doubts with recursion, right? May not be all, but some part of your confusion might be cleared after this. So what is happening? Initially, we are calling this DSC with this list 1, 2, 3, 4, 5, right? Assuming, this entire explanation is based on that. We have assumed that L is 1, 2, 3, 4, 5. Okay. And so the initial call will look like what? DSC of 1, 2, 3, 4, 5. That's our initial call. Now what happens? So the length of L is not less than 1. So this if condition will not execute. We will come down to this return statement. And this return statement, what we are doing? last of L, that is 5 is separated out inside a square bracket, plus plus, we are making another call to the same procedure, which is that recursive call. And in this time, it's a init of L. So that 1, 2, 3, 4, 5 now became 1, 2, 3, 4. So what happened is the initial call, right? The initial procedure which was executing with 1, 2, 3, 4, 5 is suspended. It is not yet completed, but it is suspended. It is waiting for something else to happen, right? So it is suspended, and this new procedure call started, which is the ongoing one. That's why it's colored in green. I mean, just understand that. Okay, yellow is the suspended one, and green is the ongoing one. Okay, same thing will happen again with this 1, 2, 3, 4. 4 is separated out, and another procedure call will start with 1, 2, 3, 4. 1, 2, 3. Right? 4 won't be there. Right? This is what will happen. The 5 was already there. Now plus 4, because that 5 was from first call. Now 4 came from second call. And now the this procedure call is going on, which is 1, 2, 3. Same thing will happen again. 3 will be separated out. Next procedure call with 1, 2. Now 2 will be separated out. Procedure call with 1. And now this is the point when we stop this recursion. That's why I said stopping recursion is very important. Now what is happening is, what is the length of the list is 1, right? So now what the condition is, length of L is less than equal to 1, which is the case, we return L. Return L as in return this 1 in a square bracket. That's it. There is no more recursive call. So the answer will look something like this. It will just say 1. And now because it returns something, this procedure call is completed because it actually returned something. The execution finished. It didn't call something new, which was happening in these yellow ones, right? They called the procedure again. They kept calling the same procedure again. But when we call the procedure with just one value in it, one value in that list 1, it simply returned. It is not calling procedure again. It is simply returning. So it returned. So we got 1. Now we will keep closing. I mean, initially when this thing was happening, right? We were suspending the execution and starting new calls. Now we have reached the point when recursion is stopped. Now we will start closing these suspended calls. I mean, start completing these suspended procedure calls. So this one is completed now. Now as this one is completed, this operation can be performed. 2 + 1, it can be executed, right? As we can do this 2 + 1, this procedure call of 1, 2, which actually triggered this last of 2 plus init of 1, right? That can be closed. That can be completed. So that's what will happen. That is what will happen. So 2, 1 can be merged together. Same thing now 3 and then 2, 1 can be merged. Same thing with 4. Same thing with 5. And that is how.
Can you explain the last part?
Yeah. So that's how the this
sir, in this
particular
only-
procedure. Yeah,
so in
just
this
let me
only-
finish. Let me finish.
Okay.
Guys. Yeah. So that is how the general idea of recursion is. You start calling procedures. So you suspend initial call and generate a new call, and then you reach to a point when no more recursive calls are required, and you are in a position to return the actual value. And that is when you start completing or start closing those suspended procedure calls. That is the standard practice. Okay. So I believe that's the last slide from this question. Okay. So whoever has a doubt with this entire
Sir,
procedure, right,
I wanted
please.
to ask something.
Yeah.
Like
Yeah.
you said that like the first time like 1, 2, 3, 4, 5 that will be green in color, and then later it will be suspended, and
Correct.
that time you kept 5 as a list separately, right? And then
Correct.
you put plus and you put 4 as a list, right? So sir, I wanted to ask when this process is happening, that time where this 5 as a list plus 4 as a list getting stored, where it is getting stored in the system.
Okay. I'll tell you. I mean, this is a bit complicated. This is beyond our syllabus. So I will try to explain it in a very naive way. Try to understand it. Otherwise, anyway, leave it. Don't worry about this. See, computer system, right? In a general computer, it has something called a stack. Okay. I don't know whether you have heard about it. It's called stack.
Yes.
Internally,
Yes, sir.
you will know there is something called as RAM in the RAM is there in your computer, right? Your random access memory, right? The temporary storage. So in the RAM, there is some area of that RAM is allotted to stack. The stack is used by operating system for various reasons. This is one of that reason. So all these procedure calls information, right? Just look at this right side, right? Where this green, yellow, red thing is happening. If you see, originally it was just one call. On top of that, we added another call. On top of that, we added third, fourth, fifth. So we are stacking those calls one on top of each other, right? That's the concept of stack. Stack of books, stack of cards, same thing, right? That's the place from where that stack or pile word came from, even in our CT initial lectures, right? Remember?
Stack is also means data type.
Yeah, it's actually
Yeah,
it's
so
not data
that-
type, it's a data structure.
Yeah,
So,
data structure.
yeah,
So,
that
sir, that means there is no variable here which is storing
no
the
variable.
value.
No
but it is-
variable is storing.
Yeah, it is storing somewhere in the RAM, and when the value is returning, that time it is appending in the list. You mean
Correct.
that, right?
Correct.
Okay, then I got it. Thank you.
Sir, my question was means
Uh-huh.
after all the procedure calls, what is the reason that it is going to append all those values in a list? Again, like you said, no, 2 and 1 merged, then 3, 2, 1 merged. So what was that condition?
No condition. This line is written, right? What is
Yes.
happening? Okay. What we are saying, last of L plus DSC of init.
Yes.
What does that mean? When we use plus operator, what computer is supposed to do? It is
We are
supposed to
going
merge
to
those two
append
lists,
something.
right?
Yeah.
It is supposed to merge those two lists.
Yeah.
But now the problem is last of L, we know it is 5.
Hmm.
Okay, let me go back to that slide. Okay, we know that last of 5 is okay. This last of L is 5. That part is known to us. But do
Yes.
you know what is DSC of init of L?
No.
No, right? So unless and until you gather that information, your plus operator, plus operation cannot be completed. Correct?
Okay.
So
Yes.
you put that operation on hold. That is what the suspended part is.
Suspended is doing. Okay.
So you have to suspend it, right? Unless and until you get this result, this operation cannot be completed.
Okay.
Okay, correct? If I tell you what is the value of 5 plus x, tell me
We
the
don't know that.
tell me the integer value of 5 plus x. What you will say, I cannot perform that operation unless until I know what is the value of x.
Value of X. Yes.
Correct? Same thing is
Yes.
happening here. I cannot do this
First, we will process
operation.
X.
Sorry?
First, we will process X, then we will add 5
Correct.
plus X.
Absolutely. So unless and until you get the value of DSC of init of L, you cannot do this plus operation. That's why you put that 5 separately plus and now waiting for this result.
Okay. So once we separate everything, then we merge it back.
Correct. Because we are waiting, right? The suspended procedure calls are waiting for some result to come to them in order to finish their process.
So for each iteration, we are separating, and then at last, once everything we got the result, then we are appending it back.
Correct. Because when we reach to this position, now when we say DSC of 1, we can actually get the value. Now we do not have to wait any longer.
Yes.
Because we can say return L. Right? Return L is not dependent on any, that X part is gone now, right?
Yes.
Because we know what is DSC of 1. DSC of 1 is just list with one element, which is 1 in this case, right?
Yes.
Now, once we have this result, this operation was pending earlier, right? What is DSC of 1, 2? This was pending. Now it can be completed by saying 2 plus 1.
Okay.
Correct. So that's what we did. Now
I got it.
This one is completed, and same thing will be continued for all the suspended.
completed, we will just merge everything back in single step.
Correct. I mean, not single step. Every procedure call will finish its pending task.
Okay.
Now these two are closed. This yellow one, the topmost yellow one, it was waiting. It was waiting for what? It
Adding
was
up
waiting for DSC of 1, 2.
1, 2, 3.
Right? No, 3 was separated out because of last of L. Right? Because of last of L, 3 was separated out, but it was waiting for DSC of 1, 2.
Okay.
Okay, but now we know what is DSC of 1, 2. DSC of 1, 2 is 2, 1 in a list.
Okay.
So now it can be completed by merging 3 into it. So this is what now that yellow became red.
Got it, sir.
Got it? The same thing will be continued till we reach the last step.
Okay, sir.
That's how recursion works. Okay. Yeah. Any more doubts with this?
Is recursion is good idea to use?
Yeah,
Because
why
you can
not?
do without-
Why not? So it's easy. I mean, at this point of time, you guys might think that why to complicate all this and it's too difficult. But trust me, there are many questions where recursion is actually the most easiest way of implementing the code. You don't
But
have
it
to
seems-
write many things. So assume you are supposed to do this without recursion. You will have to write a separate loops for it, right?
Yes, sir. But it seems that it is suspending lot of things. So it
Yeah.
seems that it is consuming lot of memory. Means,
Yes.
Is it so?
Yeah.
Yes, if you have to build a system which use very less memory, then is
Correct,
recursion
correct.
a good idea?
See, actually, it doesn't take that much of memory because the stack is sufficient enough, as I said, to handle this. Unless and until you are dealing with huge amount of data, the memory won't be an issue. And anyway, if you are dealing with huge amount of data, then no matter what your approach is, even though what is the alternative to recursion? Write a loop, right?
Iteration.
Right, by iteration. And even in case of iteration, you will be iterating on it the same list, right? Element by element.
Hmm.
So anyway, the memory is required.
Okay.
Right. So
Okay.
it has, I mean, memory wise, recursion or non-recursive.
But it seems like loop handle only one variable, but it seems like it is very CPU intensive. I do not know it is like so, but it seems like it is calling procedure
Yes,
again and
yes,
again.
that part I agree. It is not. It's not adding any overhead on memory, but it adds some extra burden on processor. That part is correct.
Okay.
Processing wise, it is complicated, but why you are worrying about it? Computer will manage it. Don't worry. Okay, this is nothing for a computer.
Actually, for us, processing is also tough.
Agree. That's why I said recursion is tough. I absolutely agree, and I won't deny it. It is tough. It is one of the most common topic where most of the people have confusion. Okay, and that is why, as I said, right, we'll be having a separate session dedicated to this.
Yes,
For
sir, but
very
this
reason that it is
imagination you have
complicated.
demonstrated is very, very nice, sir. This
Yeah,
5,
so-
then 4,
So
then 3.
this is for this. Maybe I mean, I said for that session, I will try to demonstrate same thing, maybe with a different approach. So that if somebody hasn't understood this, might understood that. Okay. So that's the idea behind it. Okay. So if everybody is on same page with me with this, then
Sir,
we'll move to second question. Yes, Ganesh, I'm coming to you. Yeah, Ganesh. Yeah, tell me. You were asking something earlier.
yes, sir. Sir, actually, my question is a general thing that is that concatenate one. First, I have a list like a list of list, and the second operand is singleton list. So if I append together, so what's happened? That's my question, sir.
Okay. Hold on.
Because we extend to this, if I have a 3-dimensional list, the list, and I have a singleton list, so how it append? That's little bit of confusing.
Okay. Let's say this is your list.
Yes, sir.
This is nested list, right? List of list.
Yes, sir.
And in this, you are trying to append maybe
A
something
single
like
done list. That's only, sir. Ah, yeah, yeah.
this is what you want to do, right?
Yes, sir. Yes, yes.
Yeah, it is very much possible, and answer will be something like this. Okay.
Just remove one bracket of right hand side list, right?
Sir, but
Yeah.
Before 10, you didn't write the bracket.
No, the bracket is there, right? This is the outer bracket.
Yes, sir.
Just remove one bracket of RHS,
See,
right hand
this part
side
will
of
be
it.
removed.
Okay. Could you explain what happened here?
Okay, what happened is your initial, this part remains as it is, obviously.
Yes, sir.
This first element, 1, 2, 3, second element, that remains as it is, no change.
Yeah, yeah,
in that,
yes, sir.
right?
Yes, sir.
Then what is happening is the plus operator is doing what? It looks for elements inside this list, right?
Yes, sir.
And
Yes.
whatever element is there, it is inserted on inside this particular list. Or other way around. You can do from left to right or right to left. It's up to you.
Okay. Okay.
Okay. So every element from right is, we pick it and put it inside the list which is on left hand side.
Okay. In case suppose I have a list of list in right hand side, like then yes.
This is what you are saying.
Yeah. Then I have a bracket in before 10 and after 30.
Correct.
Okay,
Same
sir.
thing again, one closing bracket plus and one opening bracket. This part will be removed and replaced by comma. That's your answer.
Okay. For if I so I can able to understand this one. So
Yeah.
So if I have a 3-dimensional list plus a single done list, then that last part of that first operand and the first part of the second operand will remove, and I replace that comma. Is that right?
Correct. See, as I said, simply plus operator will have one closing bracket on left side and one opening bracket on right side. Correct? Always.
Yes, sir.
Remove this part with comma, and that's your answer. Always.
Okay.
Okay.
Yes, sir. Yeah.
Try it with any example, nested list, non-nested list, so any type of nesting, that will be your final answer, no matter what.
And one other way we can understand that why you are removing only this bracket, we can understand that we are adding element only, no? So
Correct.
remove one bracket from one of on both operand. Remove one bracket on both operand, then combine them and then make them a list by adding a last one big bracket.
Yeah.
Yeah. Yes, sir.
Okay, got it, Ganesh?
Yes, sir. Yes, sir. Got it.
Okay, that's fine. So then we'll move back to our original slides. Okay.
Recursion.
Yeah. So then shall we move to problem 2?
Yes, sir.
Yeah, Radha, you are on mute. Do you have anything to say?
No,
Radha?
sir.
No,
No.
sir. Please
No,
stop.
sir.
Okay. Yeah,
Yes.
Pooja, you have raised your hand.
So actually, I have a doubt, which is not related to the studies, but something related to other stuff. I actually gave my second attempt recently of my qualifiers test, but I could not succeed in it. So will I get another chance for that?
No, I mean, now that part is gone. You have to reapply for next qualifier along with the regular.
Okay, so for the January session, I have to reapply.
Yes, for January session.
Okay. Thank you.
Sure.
So can I continue studying this, or then?
Yeah, absolutely, no problem. You can. I mean,
So I
if you
can
want to
continue
join
this?
live sessions, we do not stop anybody from studying. So please join and study.
Okay, but for the sake of qualifying, I have to reapply for the January.
Yeah, absolutely.
Okay, thank you, sir.
And for that, syllabus will again be first 4 weeks. Then this week.
Yeah.
will not-
And so I have to resubmit the assignments and all this
Yeah,
stuff.
it will be considered as fresh application.
So fresh. Okay.
Yeah.
Okay, thank you.
One doubt, sir. You said
Yeah.
this procedure when you are doing the DESC inside, it is not going to affect the memory part, but the speed of the program, the output will be little delayed, right?
Yes.
Because it is keeping on calling the procedure again and again.
correct. I mean, there is a long
Most
debate on this, whether recursion is fast or recursion is slow. It actually depends on your input list.
Input list, yes.
Okay, if input, it depends purely on input list size and what exactly you are doing.
Okay.
So it depends on the application for which you are writing code. In some cases, recursive procedure is faster. In
Yeah.
some cases, the iterative procedure, I mean, the iterative approach without recursion is faster.
Yeah, while.
Yeah, while or for is faster. So this
yeah.
is something, it's a very long and big debate.
Okay.
And that's something is there. I mean, that's not part of computational thinking, but that is there in one subject called as PDSA, Programming Data Structures and Algorithms using Python. So it is algorithms part of computer science, okay, where we discuss various algorithms and compare them to find out which one is better.
Okay.
So that's the part where this will be discussed. And again, that course is also taken by Professor Madhavan. Okay. So you will, but that's in diploma, quite far from now. But don't worry, you will know the insights of all this.
Okay, sir. Thank you.
Sure. Thanks.
Sir, one problem we are facing, sir.
Yeah.
We are studying from IIT Madras.
Yeah.
But if someone asks, okay, I am going to buy a computer, there is DDR4 RAM, there is DDR5 RAM. Should I purchase this DDR4 RAM or DDR5 RAM? And
Hey, what is this?
I do not
This is
know
not a
that,
computational thinking question.
Actually, not a computational thinking, but we are studying computers, so there should be a course on this technicality. We should know which.
Okay, you're saying about some hardware.
Which computer
course.
system. And how.
Okay, you're asking about some
No,
hardware.
not course, but basic things.
Yeah, okay.
Means that kind of thing. One course should be there, I think.
Okay, sure.
We are studying from IIT, so this much knowledge.
Yeah, I
we
understand.
should have.
I got your point. I understood what you're trying to say. Okay, let's see what we can do.
And I recently understand that i7 processor of 11th generation is low power than i5 processor of 12th generation.
So there should be a
There is a generation
Yeah,
gap.
guys,
all these
let's
things
not
after all
deviate
final.
from the intention here.
Yes, sir.
Let's continue with the question.
Sir, it will be better if you go to the next question.
Yeah, let's move to next question. Yeah. Okay, so this is problem 2. Read it out, then I will move to the slide where you can submit your answers. Try to understand this, what is happening. If not, then let me know. I will explain what this list is all about.
Okay, sir, can you please show the next slide?
Sorry. Okay, so quickly, let me just go through it. A robotics student is designing a line following robot. The bot can either move one step left or right, one step at a time. The sequence of moves of the bot is recorded in a list called moves, like it is shown here. So what we are doing, you are supposed to write a procedure that accepts the list moves and return true if the bot is the same place, right? So you have to follow that sequence. So in this particular sequence from left to right is what bot has done. That means bot started from, let's say, 0.00. It went one step left, then right, then again left, and then right. And that's where it is stopping. What you have to is, what you have to figure out whether this is the origin, or whether this is the origin or the point where it started or not. If it is the same, you are supposed to write true, else false. That is the idea behind this question.
So
Now,
I have a doubt.
now let's look at the pseudocode.
Yeah, sir. When it's true, when it's written true.
It returns true when bot is at the same place, the place where it started from.
That means that robo is moved and coming to that same
Came
origin.
back to the original.
Okay, came back to that original origin.
Or
Okay.
maybe did not move at all. That's also a possibility.
It doesn't move anything, then that's also written true.
Yes.
Okay, so okay.
Okay, so it's a combination of two procedures. So this is the main procedure where we are returning true or false, and then this procedure is calling this the left hand side procedure is calling the right hand side procedure to figure out whether to return true or false. So this is the line which you are supposed to figure out. Once again, this one is a recursive procedure. As you can see, the numeric of rest is there.
Sir, what was in previous page? I'm facing difficulty to understand what was said there.
What was?
What was said there in previous page?
Okay, the previous page, you have a list of moves which bot has taken. It consists of only two values, left and right. So it's like you're standing in a place, you take one step towards left, take another step towards left. That means you have moved 2 steps towards your left. Now you take maybe another 2 steps towards your right. You came back to your original position, right? So 2 left followed by 2 right is equal to nothing, right? You actually started from some point and came back to that original point. So if that is the case, you are supposed to return true. And if that is not the case, that means you haven't came back to original place, then you are supposed to return false. That is what this particular procedure is.
Sir, are you not going to give us option?
No. In this case, the options are not there. You're supposed to type the entire statement.
Oh my God.
Okay?
Yes, sir.
Yeah. Hey, what's the fun in that? You are here to become programmers.
Yes.
You have to write code.
Sir, in exam also we'll have to write, type the code.
No. You do not have to write code in exam.
Okay.
In exam, it's always MCQ, MSQ, NAT, the same pattern from quiz 1, quiz 2, same thing.
Okay.
Yeah. Luckily for you, the TCS, the exam partner, right? They don't support that kind of questions. Otherwise, we would have framed those questions.
They know us, no?
No, for that we have programming exams. I mean, when you start Python, there will be programming exams where you will be given a blank screen and given a problem statement, write the entire code. I mean, of course, you have to become a programmer, right?
That move is the list, no, sir. That left.
Yeah, it's a list. Correct. The variable moves is a list.
Right. Sir, I'm doing.
Yeah.
And this is some recursion. It will give some recursive statement, right?
That's something you have to figure out, right?
Yeah. Okay, I did it, but not sure.
See, okay. What is the possibility of values in moves?
Anything, left, right.
That's it, right?
Yeah.
There can be only 2 values, left or right.
Yeah.
So for left, we have written some code. For base condition, we have written some code. So else part is for what? Else part is supposed to be for right? If the value is right, what you will do?
Yeah. Okay.
So consider that part. So if right is there, this is what you are doing.
Yeah.
If
Yes,
what is left,
I did this like this only, but
Ah.
not sure.
okay.
Can I say what what I did?
No, wait.
Okay.
Let everybody submit, then we'll.
Okay.
Yeah.
Oh, I have to write. I wrote in
Yeah, you're supposed
book.
to write there.
I wrote in books. I forgot.
No, you're supposed to write on peer deck. Then we will see. I will share that screen where we'll see what all answers I got.
वो इधर side.
Yes, sir. Right.
Okay, so only 7 responses so far. Guys, don't worry. Just write whatever you
Just
feel.
give me a minute,
is
sir. I'm
correct.
writing. I forgot to write.
Yeah, sure. Take your time. So everybody, please write. I mean, even though it's wrong, there is nothing. It's absolutely fine. We are just here to learn. Okay, so it's absolutely okay to make mistakes.
Sir, for this question is okay, but I can connect with real life because that moves doesn't tell about the robot is coming that origin or not, because left, right. Maybe I can connect to how this robot again from this moves, how I imagine that robot is again come to that origin. So if any diagram is given to that one, then I think it will clear to write that code.
Okay. But right now you can also draw the diagram, right? So see, it's a simple robot. Can I only move left or right? There is no any other movement.
Yes, sir. Suppose if that path is starting at one point and ending at another point, or starting at a point and it follows some path. Because our list contains only 4 values.
Only 2 values. I mean, 2 types of values. It can be not 4 values. Can be 400 also. But all values will be of 2 type, either left or right. There is no possibility of third type. It's
Yes.
a list of strings, right? It's a list of strings, and there are only 2 types of strings, left and right.
Yes, sir. But our moves.
So can we move to the answer part, sir?
Yeah, sure. Just hold on, Shubham. We are discussing it. Yeah.
Yes, sir. Actually, our moves is not sometimes is not enough to coming to that same origin, because our robot is stuck in somewhere in the middle or just.
Yeah, then you will return false, no?
Okay.
That is the idea behind it.
Okay, sir. Okay, after showing that answers, could you explain the diagram also?
Yeah, I mean diagram. I don't know. I mean, how can I draw a diagram? But I don't think it will be required. I think you're thinking too much about this, which is not required actually.
Okay, sir.
2 minutes. I done, sir.
Yes, sir. We did it, I think.
Okay, sure. So I have some 12 responses. Let me share those. Then I will come to the answer. Okay, Naren, you have raised your hand. Is it you have understood the question, right?
Yeah, I've done, sir. Initially, I thought in different. After we spoke and after you gave some answer, I changed it. Like I thought the well, left means it will go left. Again, it will turn. I thought there is a what do you call the robot can turn itself so that it will go.
No. There is no. That's why I said you guys are thinking too much. You
then
just
I thought,
don't have
okay,
to think
either
about
it can
anything.
go in the one axis only. It can go move.
Correct.
It can go away from that axis.
Correct. It will not move on that axis. It's like a track, right? On a track, it can go either in one direction or the other direction. That's all.
No, that's it. It can move only in one axis. Actually, it cannot move in 2 axes.
Correct.
So accordingly, it will change. I was thinking also in the same line what he was thinking.
Correct.
Can it move from x 0 to it come to 1 in x axis?
Why it is moving in
then
one
left
axis?
means 1 to 1, 1, it will move. It is not like that.
Yeah, right.
Okay, sir.
But why it will move in only one axis?
Yeah, only on one axis. It's looking only left and right? There is no up or down.
Yeah, but when it move left, then their left side will change, that will be in y-axis.
No, it is still, say, consider x-axis. You are on x-axis. You are at 0, 0. You are on origin. You took one step towards left.
But when we take left, then we have to turn, no?
No,
we
you
have
don't
to
have
turn,
to.
then
That is
our
my
left
point.
hand and
You
right
don't
hand
think
will
about that turning and all that.
turn. Okay, sir.
Just you took left. You went to what? You went to -1, 0, right? Sorry, 0, -1. Well, I mean, it depends whether you're on X or Y, whatever you consider. But it's just one step towards left. Consider yourself standing on a floor. You took one step on left, then one step on right. You are back at your original position, right?
Yes,
As
sir, yes,
simple
sir.
as that. Don't think about turning and any of that stuff. Okay, let me see the responses and then we'll look at the answer. Then we will come back to the discussion if required. Okay, so this is what people are returning. Return, okay, rest of L -1, L -1. Okay, most of the people have written this numeric of rest of L -1. This L is supposed to be capital, one small mistake. If assuming that is correct, but okay. This is not enough. You will require a return over here, right? Okay. Return of numeric of rest of L -1 is the most common answer I got.
Is that correct, sir?
I believe so. Let's see.
Let's see.
Yeah, let's see what happens. Okay. Okay, so this is the question. Now we'll try to figure out what is happening. Okay. So the correct answer, I mean, I thought it will appear at the end, but yeah, it appeared immediately. So that's the correct answer.
Sir, by mistake, I forgot to write return.
Okay, yeah, that's fine. So return of numeric of rest of L -1. That's the correct answer, which most of you got it. So let's see why this is the answer and how the entire execution is going on. Consider this is our list that moves. List contains these values from left to right. Okay, left, right, right, left. So what happens? Left we can consider, I mean, being on x-axis, left is like a -1 and right is like a +1, right? You do +1 into the existing value. So you took when you went left, you are on at -1 point on x-axis. You started from origin 0, 0. Now you are at -1. Then you took right step, that is -1 +1, which is 0. You came back to original step. Again, right is +1, left is -1. So ultimately you are at 0, 0. So actually what you are doing is simply you are counting how many times you went left, how many times you went right. If both these numbers are equal, you are at original place. If the left number is higher, that means you are somewhere on the left side. If right number is higher, then you are somewhere on the right side. That is how the original idea is behind this whole question. Okay, no turning, nothing, no moving of axis,
Yes,
nothing
yes.
of that nature.
Yeah,
Okay.
yes, sir.
Yeah. So now looking at the computation or the pseudocode. So that's our first, right? So first of all, we removed, we processed it, kept the rest for next iteration, for further that recursive iteration. That is what we are doing here. So left, you processed. When it is left, what you did? You did that -1 part over there, right? As we said, moving left as in on x-axis, it is moving towards -1, -2, -3. Consider there are 4 left. 4 times you move left. That means you are at -4, right? That is what is happening. So that's why, I mean, consider that left being -1 and right being +1 is what the entire logic is based on. Okay, and the answer was there actually. I mean, this line was there, right? Return of numeric of rest of L +1. So for right turn, if we are doing +1, then definitely for left turn, it should be -1, right? So that hint was
The S part is there, that's why it is easy to fill the gap.
Correct. I understand. Yes.
Sir, I
The
did-
reason behind putting this question is to teach you this concept is there is a possibility of two recursive calls in the same procedure. Okay.
Yes, sir.
Yes, sir.
One recursion is for left and one recursion is
Yes,
for
there
right.
is a different type of recursive call for left and a different type of recursive call for right. So this is also possible and it is required sometimes. Okay. So that's the learning from this question. That bot moving and all that, that's just some story involved in it. Story is not important. The part you should remember is this. Okay.
Yes, sir. Sir,
Okay.
actually, that diagram is simply one-dimensional x-axis. That's fine because I'm
Exactly. That's why I said diagram is actually not required for this.
Yes, sir. Yes, sir. Clear, sir.
Yeah, clear. Okay, sure, great. And then this is the same thing what we have studied earlier. I'll just quickly run through it. If you have a confusion, please stop me immediately. So we are executing this procedure with initial list, which is left, right, right, left. Now then that call will be suspended because first value is left. So that numeric of rest of L will be called again, and -1 is kept outside separately, right? So that -1 remains, but this subtraction operation we cannot do until we get this result. Result of what? Numeric of right, left. We, unless and until we get this data, we cannot do -1. Just like what we did last time, right? Last time the plus operation was suspended. Now the subtraction operation is waiting for that result, for its left operand. Same thing. Now because of right, the +1 got added into it, and now we are waiting for this result, right, left. Now that result came. Now this result came. After that, now it's an empty list. Remember, this is also a procedure call which will happen. So in exam, if somebody asks you how many times the procedure will be called, you have to count this one as well with empty list. Okay, because trust me, there might be some question. I think there in the graded assignment also there might be some questions.
Yes, sir.
Right? How many times the procedure was called?
Yes.
Not
Right?
in graded.
Maybe in practice assignment.
Practice. I have
Yes,
a
sir, in
question.
practice
Sir,
assignment.
I have a doubt in that, sir.
Yeah,
After
that's
we finish
something
this, I
we
will.
will. Okay, we'll discuss that separately. Okay, let me finish this first. So, in order to answer those questions, you should understand this right side, this stack. I mean, the technical term is stack. You call it whatever you want as of at least for now. So this particular call is very important because this call will actually stop the recursive procedure call, which is this base condition. Base condition always executes only once. Remember this term, what I'm telling you. Okay, base condition always executes and it executes only once. That's the basic principle behind recursion. Okay, no matter what your procedure is, what your purpose is, it will have base condition, it will execute, and it will execute only once.
And after that, CPU process will be
after that, the
less
recursive
intensive.
calls will be stopped and all the suspended calls will be completed. Which
Immediately,
is what
right, sir?
Yes, which is what will happen now. Because numeric of empty list will return what? It will return 0. Now what you have is 0, -1, +1, +1, -1. That is now possible. I mean, anybody can process that information. Earlier, now this
Sir,
nobody can process.
Sir,
This
it is
one?
like
Yeah.
climbing a stair one step by one, but at the end, the whole stair gone and we just free fall.
Correct. When you reach at the top, you should come back step by step. Don't jump from there, right? That's the idea behind it. So,
but it is free fall. Everything is closing suddenly.
Correct. So no, it's not suddenly. Step by step, it is again closing. Right? See, that's why just observe this. It's not directly. I'm not making it red. Step by step, it will be closed. So that 0, -1 operation will happen first. Then that +1 will happen. Then +1 will happen. and then -1 will happen. And then finally your result is 0 because that's how the numbers stack up. Okay. And as it's 0, your final answer will be true, because that's our the first procedure. The left hand we had another procedure, right? This one. If the returned answer is 0, we return true. If it is any non-zero value, either negative or positive, we return false. Understood this one?
Yes, sir.
Okay.
Yes,
Any
sir.
doubts in this question?
No,
No,
sir.
sir.
Okay.
That
Sure. Right. So then we'll move to next question. Now that is based on DFS. Yeah. So this is DFS. So no pseudocode involved in this question. Let me first see how well you have understood DFS. Then we'll go to the pseudocode part. So this is that's why it's a problem 3 prelude. Okay, this is not actual problem. Actual problem 3 is afterwards. So what I want is, I want just the sequence of these vertices which will be visited by DFS in particular order, starting from 0. And as we have studied in lecture, if there is a tie, right? If there is a tie between multiple vertices, visit that vertex first, which has the lower number, right?
Done,
so,
sir.
Yeah, only one person finished. So just others also try to finish it. So as per DFS, we are supposed to start from 0. So possibilities are what? 1, 4, 5, and 2. So select the one which is with least number, right? And then keep going and complete the get me these numbers separated by comma or spaces or something, so that we can move ahead quickly. 30 seconds.
Yeah, sir.
It should not take more than that. Even that is too much. Okay. So shall we see what the responses are, or do you need some more time?
We should see, sir.
Yes, sir. We will go.
All done? Okay. Let's see what people have submitted. Okay, so this is what we have. Oh, the options were there. I thought you're supposed to type in this case also. Okay, then it was easier, right? Just select one option. Okay, so most of the people have selected option C. Only 2 guys have selected A. Fine, no problem. Let's see which one is right and so on. So what happens is, we start from 0. So from 0, there are 4 options where we can go. From 0, we can go to 2, we can go to 1, 4, or 5. Is there any? Okay, slides are there. Yeah. So that's why actually number of slides are huge. For every change, there is a separate slide. Or we have already reached to this number. Okay, so from 0, this is the ongoing one. Again, the same, suspended and completed. Okay, because DF is also a recursive procedure. So it will also follow that, that same pattern. So we start from 0. Now we know out of 1, 4, 5, 2, we select the vertex with lower value, right? Lower vertex tag. So that's 1. So from 0, we went to 1. But still 0 is not completed. Why 0 is not completed? Because 0 originally at this point 0 has 4 neighbors. Right? We call it neighbors. 0 has 4 neighbors, 1, 4, 5, and 2. We selected 1, but 3 are still incomplete. That means 0 has to be put on in a suspended mode. So 0 is suspended, we went to 1. From 1, again, from 1, there is now only one possibility, which is 3. So there is no way we can do anything else. So we went to 3, right? So from 3, now there is a possibility between 4 and 5. Now, between the smaller ones, we are supposed to select 4. From 4, now there are 2 possibilities, but both are already covered, right? 0 and 3 are already suspended mode, so in a suspended state. So we cannot process those. Now this is the point which is important. This is the place where 4th is completed, because for 4 there is nothing is pending, right? There is no suspended or unvisited vertex for 4. So this is the place where we complete the 4. Now why we move back to 3? We move back to the previous vertex, which was visited before 4, right? So what was observe the list? What was there before 4? It was 3. So you go back to 3 and start processing again from that point. We don't go back to original state. We just go one step back. Okay, so when you took one step back, which is 3. So from 3, now there is one more option is there, right? Which we left earlier, which is 5. So because of that, now 5. From 5, now if we go further from 5. From 5, it has to be 6. From 6, now nothing is there. We have to go back, step back, which is 5. At 5 also, now nothing is there. We have to go back. From 5, step back is what? 4, but 4 is already closed. So another step back, which is at 3. At 3, nothing is pending. Step back to 1. Again at 1, nothing is pending. Go back, 0. At 0, now there is one element, one vertex pending, which is 2. Complete that. At 2, we again check. 2, nothing is there. So complete 2, came back to 0. At 0, now check everything is completed. Yes, it's done. Nothing is pending. Close 0. And that's our final answer. Okay, forget about pseudocode is something, we'll come to that later. If you have understood how it is done in general, then we can move to pseudocode. Yes, somebody was
saying. I think this was not in options, sir. This option. I was searching for this.
This one is not there.
It is there.
Yeah, I think it is there, and that's what most of the people selected.
Sir, can I ask you one question related to
Option
this?
C might be.
Yes. Yes,
Sir,
Tarika.
can
I
you?
think there is mistake. Could you show that again?
Yeah, I'll come back to this. Let me answer her. I'll move. I mean, I have to move a lot of slides. So let me finish this and I will move there. Yeah. Yes, Tarika, tell me.
Sir, can you make a tree diagram out of it?
Yes, we can, and we will.
So can you make it now, or can you tell after the slides?
No, it is there as part of the slides. Don't worry.
Oh, okay.
Yeah. Just wait. We'll come to that. Okay, it is there. Okay. Anything else? Okay. So this is 0, 1, 1, 3, 4, 5, 6, 2. Yeah, that was the answer, I believe. Yeah, that's 0, 1, 2, 1, 3, 4, 5, 6, 2. That's what people submitted. That's correct.
Okay, sir. Sorry, sir.
Yeah. Okay. So I move too much. Okay. So Tarika, now see, those are the next slides coming up. Okay. This is enough. We got the list of vertices which you have visited in some order and so on. But what is DFS? Depth first search, right? The input given to DFS is always a graph, and the output of DFS is always a tree. But this is not a tree. In a tree, we cannot have cycles, right? So we have to generate that tree from this graph. How that is done? That is the next step. Okay. So now let me go through this particular procedure again in order to tell you how that particular tree is generated during DFS. Okay. So same thing. We again start from 0.
I have one doubt in that.
Yes.
While we're moving from node 3 to node 4, we
Uh-huh.
close the node 4 after that.
Correct.
Similarly, why didn't we close the node 1?
Okay. So the thing is, when we actually at 1, right? We what we saw at 1, there is a possibility of node which is 3. Correct?
Okay. Yeah.
3 wasn't completed.
Okay.
So you cannot complete 1.
Okay.
You are getting my point, right?
Only when we return back that path, we complete, close everything, right, sir?
Exactly.
Returning is last option.
Remember that recursive procedure calls. What you do, you separate out something, either last of L, first of L or something, and call that procedure again. Unless until that results come back, that last of L or first of L is still waiting, right? You cannot complete it. Same thing is happening. At 1, what you did, you called DFS procedure again with 3 as an input.
Yes.
Unless and until that result comes back, you cannot close 1. With 4, it was possible because from 4, because there was nothing to call, right? At 4.
Okay.
So we were able to close it. But at 1, that was not possible because we made the call with 3.
Okay, it's clear now, sir.
Okay. Yeah. Anyway, I'm just telling you this hypothetically. Later on, we will use the same example along with pseudocode, so that this will get cleared even further. Okay.
Okay, sir. Thank you.
Yeah.
Sir, we don't close 1 because it's connected to 3. Sir.
Yes, correct. And 3 is still going on. Okay, so let's construct that DFS tree, that depth first search traversal tree. Okay, so the same thing, this list will be same, but there will be additional information I will be showing on that graph side. Okay, something called as parent and child and something of that nature. Okay, so from 0 we move to 1. So 0 became parent of child. Okay, that is the general terminology used with graph. I believe if you have studied math 1 graph theory, it will be there over there as well. Okay, so that's the hierarchical structure, right? In a tree, there is always this parent and child structure. So from 1, we move to 3. So now 3 to 1 is a parent of 3.
Sir,
and 0 is a parent of 1.
Sir, could you explain what is the meaning of hierarchical structure?
Okay, hierarchical structure as in just this particular arrow thing, right? There is some someone is at the top, then someone is below that, then someone is below that, and so on.
Okay, sir.
Something like a family tree.
Yeah, like a family tree, or see
grandfather, father, child.
Correct. Or if the simplest one which you go face every day. Most position, then vice principal is below principal, then maybe a class teacher and so on, right?
Yes, sir.
The same hierarchy. The president is at top, the prime minister is there, then chief ministers are there, and so on, right? So it's a hierarchy. That's what is happening here.
Okay, sir.
Yeah. So that's what is here is happening here. Your now 3. Now from 3 we visited 4. So there is a observe these arrows also, right? That is what the arrows are constructing that tree. So from 0 we move to 1, 1 to 3, 3 to 4. From 4 we did not move to new node. We came back. So for that we don't need arrow. The arrows will be added only when we explore new vertex. Okay. So from 4 there is nothing new to explore, nothing new to visit. We came back to 3. We closed 4, came back to 3. From 3, now we visited new vertex, which is 5. So 3 is the parent of 2 vertices, 4 and 5. Okay, it can be even more than 2, possible, depending on how graph is structured. So now from 5 we move to 6. There is nothing to do from 6. Nothing remaining at 5. Nothing at 3. Nothing at 1. The same thing what we studied earlier. We back to 0. From 0 we went to 2. Nothing at 2. Went back to 0. At 0 now everything is done. we close it. Now at this point, there are, if you observe, there are two types of edges, the edges with arrows and edges without arrows. So edges with arrows are supposed to be retained in the tree, and the edges without arrows are supposed to be removed for the final answer, because original graph had those edges, but in the final answer, the output tree, right, that DFS traversal tree, in that tree, those edges are not required. So that's why we will remove this edge 04 and edge 05. The remaining structure is our tree, that DFS traversal tree. Okay, I mean, instead of removing, we just grade it out. So this is our final tree will look like. 0 at the top. 0 will have 2 children, or 2 and 1. Below 1, there will be 3. Below 3, there will be 4, 5, and below 5, there will be 6. That will be our tree. Just consider like this: hold that 0 and hang it. Right? Consider it like maybe some balls are there and they are attached with a string. So you hold one ball and just hold it. I mean, just lift it
Like pendulum.
So yeah, like pendulum. So everything will fall down below it, right? So 0 at the top, there will be 2, there will be 1. Below 1, there will be 3. Below 3, there will be 4, 5. Below 5, there will be 6. That's how it will look. That's the final tree. Is it clear?
Yes, sir.
Yeah.
Now I can draw it.
You can draw it, right? Yeah.
Yes.
So this one is
You
clear.
should have a eraser at the last.
Okay.
Yeah.
So this one is clear, but I still have question. Maybe we can discuss after all the slides. It's related to activity 2. In that also we have to make a tree. I mean, the options are there.
That one,
yeah,
if
then
we have time, maybe at the end we can come to that.
Yes, sir. Please, we will discuss that.
Sure.
Okay.
Okay. So this is what part to note here is: list is not sufficient enough to store this entire information. List told you the sequence in which the vertices are visited. But just by looking at list, you cannot tell who's parent and who's child. Right? So for that, we required some additional information. Right? This arrows, right? Arrow has two things. One is the starting point and the ending point, the source and destination of an arrow. I mean, this age. Age is from 3 to 4. So 3 is the source, 4 is the destination, or 3 is a parent, 4 is a child. This information has to be stored somewhere in a different manner. List it's not sufficient enough to store that information. Can you tell me what we can use for that?
Dictionary.
Yes, we use dictionary. So for key 3, we can have 4 as a value, or other way around. I think it's other way around might be better, but anyways, that's something we'll discuss in pseudocode. Okay. So dictionary is an additional data structure we will use along with a list. So list will tell us in what order the vertices or the nodes are visited, and dictionary will tell the relation among those. Okay. Now we'll come to pseudocode. But I mean, that time we'll talk about this further, but just remember this part. Okay. Sometimes only one data structure isn't sufficient.
Sir,
you might require multiple.
Sir?
Yeah.
So the list will tell you the DFS part and the dictionary will tell you the tree part.
Correct.
Okay, sir.
No, I mean, you should not treat it like that, because DFS is a combination of both.
Yeah, but in this this DFS, when we tell the nodes that are visited, that is given by the list.
Yes. So see,
whereas the dictionary, it gives us which is a parent, which is a child, everything.
Right. See, actually, both things together is called DFS.
Okay.
So DFS has two components. One is order is important, in which order they are visited, and second,
the tree.
The tree.
Okay.
You put both these together, that's called DFS algorithm.
Okay, sir.
Yeah. Okay. So now let's move. Okay.
But the tree already will give the order. Then why there is two things? There is one thing, only tree.
Okay, tree will give you order. Now, forget about this. I give you only tree. Tell me in what order the vertices were visited. Can you tell me? From 0.
First 0. Yeah.
How
But
can you tell
there
me
is
whether
2 and 1.
which one you visited first, 2 or 1? Can you tell me? No, right?
Okay, okay. We have to order it.
Yeah, for that.
Generally, we visit the smallest one first, no, sir?
Yes, correct. But see,
That order
but
we should
computer
explicitly mention, right?
explicitly that list is required. See, list is important when there is an order, because list has order, right? Dictionary doesn't have order. So we use the
Also list order, equal order could not be also in list. Means if 2 are on same precedency, list cannot do that.
Correct. I mean that's a different story. But what I'm telling you is, list has some advantage and dictionary has some advantage. So we use both those advantages over here. List, the advantage is it has order, so we use it for ordering. And dictionary has an advantage that there is a mapping is there, which we require for parent and child. So we use those two different data structure for two different purposes to achieve our final goal. All right. So assuming you have understood the algorithm in general, now let's look at the next question. Okay. So this is the same graph we will use, so that to keep it simple. So what we are supposed to write a recursive procedure to traverse this graph in a depth first manner, starting from any given node I. Okay. Not necessary from 0. We can start from 2, you can start from 6 or any node in between. Okay. And then compute the tree. So our question 3 is divided into 2 parts, 3.1 and 3.2. So 3.1 is about that list and 3.2 is about that dictionary or that tree. Okay. So let's start with 3.1. Okay. So this is the pseudocode. With P is that dictionary which we were talking about. S is that list again which we are talking about. A is a matrix which will store this graph, because this pictorial representation computer cannot process. Computer requires some data structure which is now matrix, and I and J are the nodes. I is that the starting node. Okay. J is some intermediate node which we will require, some variable which will require for processing. Okay, but I is the starting point. So this is our pseudocode. What you're supposed to do is you're supposed to write this one recursive line over here. Try to do it, think about it. I understand it's much more complicated as compared to our previous questions, but this is the idea, whatever idea which we discussed earlier, right? Think about it closely, you will get this answer. It's not that complicated. Remember what we did. From 0 we went to 1, and from 1 we did something. What that something is that's your answer. But only in this case, we will not start from 0. We will start from I, whatever the value of I is. Okay, I will give you a minute or two. Think about it and try to submit. Submit the answer. Once again, is it MCQ or you have to type?
Type.
You have to type, right?
Type the answer, sir.
Okay, good. That part is good. So type. MCQ is it's you might get lucky, right? You can submit something and still you get marks without
That
knowing.
part is got COD.
No, it's not. That's what I'm saying. Initially, it might look tough. Think about it. It's not that tough. See, recursively, what you are doing. Whatever you did at 0, you did same at 1. You did same at 3. Same at 4. You are repeating
It's
same
little
process.
bit like the previous type question, kind of. That right,
But
left,
I
kind
not
of.
defined, sir. Why, sir? In procedure, we are passing I. In P, we are passing I, but I not defined.
So what? Doesn't matter, right? you can process it considering I. I is a variable, right? It will have some value. You don't require that value.
Yes, sir.
See, general code doesn't require values. Even in previous questions, the values were not there. We took that for explanation purpose, for solving purpose. Original pseudocode never has values. You go back and check any of the pseudocodes, it will not have values. If the code has values, then that code is useful only for that value. But that's not the point here. Code should be generic.
Done, sir. Sir, can I ask one question?
Yeah, okay. I will not related to this answer, okay? Because others are trying.
Done, sir. I don't know. I'm not sure.
Yeah, it's fine. Nobody will be sure. So it's fine.
Yeah.
Yes, you ask the question. In meantime, others are trying. Tell me.
Yes, sir. Sir, actually, my question is, we are in this DFS, we are after finishing everything, we are back traverse. Yes, sir. So we are back traverse the previous vertex that we are coming to the parent, then parent. Yeah. So I think, yeah, no, 1 minute, sir. So I think that's happened for that written statement.
Yeah.
Written statement will help for the traverse. That's correct or right? Wrong, sir?
Yes, that's correct.
Okay, sir. That's my
Yes, I mean, what you said, right? It is correct, but I'll tell you the correct term for it is backtracking, not back traverse. Okay.
yeah, backtracking.
The
Yeah.
technical term is, and backtracking is it's very important term. Just remember this word. You will hear this later on, and that time you will know why I was saying this. Okay.
Okay.
Remember this word backtracking.
Yeah, clear, sir.
So it's a one category of algorithms come under backtracking. It is a very big concept.
Could you tell that algorithm name?
No, not algorithm name. It's a category of algorithm. There are n number of algorithms which come under backtracking. DFS is one of those.
Okay, sir.
Again, I mean, this will come in that same subject PDSA.
Okay.
Yeah. Okay, but what you are saying is correct. That return takes care of that.
Yes, sir. Got it, sir.
Sir, Kahn's algorithm also trace the trees. That is also follow the
Which algorithm?
Kahn's, Kahn.
Okay, I have to see how exactly that algorithm is designed, but ideally it should.
But it will trace the tree. So sorry, it will trace the cycle. So it is also backtracking.
No, it may not be. If it just traces cycle, it may not be.
Okay.
Because in checking cycle, you don't have to go back, right? See,
No,
I'll
we
tell
have
you
to remove
what is the principle. What is the
This is
principle of
the
backtracking?
we have taken a note separate. Then we have which have only outwards. Then we have to remove that and take one note which doesn't have any inwards. Then we have to remove the node. Like this, we have to go. If there is cycle, so there is dependency on that. So there is no not able to remove any nodes.
Okay. See, actually, what happens is a same concept can be solved using multiple approaches, right?
Okay.
So you can either go with backtracking approach, or there might be some different approach as well. That's why I'm telling you what is the concept of backtracking. I'll just quickly tell you what that concept is. Okay.
Please.
Keep going further and further. When you stuck at point, then only come back. Do not explore anything else. Just keep going straight. At some point you will stuck. That point you take one step back and explore a different route.
Okay.
That is backtracking.
This is the backtracking process.
Yes, exactly what we did last time. I mean, in that pseudocode, I mean, when we are doing that, constructing that list, right? That problem 3 prelude, what we did, right? when there wasn't anything to explore at 4. We took just one step back, which is at 3, and started again from 3. That is backtracking. We backtracked from 4 to 3 and started fresh.
Okay.
But when we were at 0, we went to 1. We did not went to 1, 4, 5, and 2. We did not do that. We
No.
decided we will go to 1. And from 1, we just moved ahead. We forgot about 0. That is the point. You keep going ahead until you stuck. You will stuck at some point, then only you take one step back and look for another option.
Yes, if there are other option, again we go ahead, or we can go back again.
When you find another option, you go ahead with that option. No, then take one more step back. That is backtracking.
Okay. Now I get it. Thank you, sir.
Sure, thanks.
Explain this 3.1 problem, sir.
Yeah. Okay. So, now just 9 responses. Numbers are going down, but okay. Let's see what these 10 responses are. Okay, it says DFS or APSJ. Okay. What this response is, I'm not understanding, but okay. Okay, fine. It's okay. Let it be like that. I won't comment on it at this point. Let's see how. Let's build up to that. Okay. Okay. So from here, let's take that example. I have just simply moved this, which most of the students have added, which is right. We get new values of P and S and call that procedure again. That's why I said, just think what you were doing in that call. Whatever we did at 0, we repeated same at 1. We repeated same at 3. Only thing, value of I changes. Right? We call DFS with starting node 0. Then we decided we will go to 1. From 1, what you did? You call DFS again, but instead of 0, now your starting point became 1. That is why that I and J2 are required. I is the current one, J is the updated one. So you call DFS again, but instead of I, this time you call with J with updated value of P and S. P is what? The dictionary, and S is that list. So update list and dictionary, call DFS again with a new node. That was the answer. And I believe most of you got it right. Few made some syntactical mistakes in typing. There were some additional brackets and so on, but that's the correct answer. Okay.
Sir,
we have
can you,
sorry.
Sir, can you please explain this pseudocode?
Yeah. I mean, I'm going to. That's what the.
Okay.
See, we are at line number 7, slide number 78. That's what there in the coming slides is all about that.
Sir, here we have to store PS, the DFS procedure. If we directly return that procedure, this is wrong.
Yes, sir, I think so. If we directly return that one, I think that's also true.
No, return will not work, right? You have to update the P and S.
Oh.
See, ultimately where your answer will reside.
Yeah, it will not return.
You see, you have to return P and S, correct? Because P will store that dictionary, which will have that information of parent and child, and S will have that information of the order. That's what we discussed earlier, right? We require both informations, and they are getting returned over here. But before returning, you have to construct those, right? Initially, P is empty and S is empty. You have to insert those values, right? That's what we did earlier. Remember that list, that 3 prelude. We constructed that list when we kept visiting nodes. We added 0 in that list, then we added 1, then we added 3, then we added 4. You remember that process, right? So that same construction of list it will happen over here. Similarly, P. The P is the that dictionary with parent-child. You go from 0 to 1. Where 0 is parent of 1. So that information should go in P. And which is actually happening. You observe this line S. What is S is doing? S is added that I. As soon as the first call happened, you added I into S. That means what? You added that 0. Now, I mean, let's not instead of explaining here, let me explain it parallelly along with slides where I have actually put in all these things. So let me go. Okay. So this time let's assume that you start with 0 from 2. Okay. From one end of the tree, from one end of the graph. Your I value is 2. Okay. Not 0. This time let's start different. It will not have much of an impact. A slight variation will be there. Okay. So I is 2. Your P is empty. P of I is -1. S is empty. Only I changes. Rest is as it is. Okay. Let's see. Let me move the slides too much. Okay. So this is where we stand. Okay. Your I is 2. So P of I is -1. P of I is P of I means 2. 2 is the key added into dictionary and value associated is -1. Why -1? Because 2 doesn't have a parent. 2 is a starting point, right? Sorry. Yeah, 2 doesn't have a parent. Because we have a parent from anywhere else. 2 is a starting point. So parent of 2, it doesn't exist. So we are just, for simplicity purpose, we are putting -1 for it. Yes.
Here we start from I is equal to 2. If we start from I is equal to 0, then what will be the value of 0?
Then for 0, it will be -1. So whichever the starting node is, the starting node will not have parent, right?
Okay, the starting node is -1.
Yeah, the parent of starting node is -1.
Okay.
Right, because the -1 is not there on the tree, but we should have some value in the dictionary, right? I cannot create a key without a value. So I have to put some value. So the standard practice is to put -1. Because usually we will not use -1 as a value for a node, right? So that's the idea behind it. Okay.
Okay.
Okay. Is everybody is with me till this point? If yes, we'll start this iteration procedure part.
Yes.
Okay. Yes. Okay. So these are the initial values. The yellow highlighted code is only executed so far. Now we'll execute line number 4. We'll call the procedure. It's taking bit to slightly more time in changing slides. So sometimes I change multiple slides. Okay.
Yes, sir.
So that's where we are. Now the yellow highlighted line is the line which is currently getting executed. Okay, just remember that. This at top, this list and dictionary will be updated. And on right hand side, we will build up that stack, which we were discussing earlier. Okay. So the entire thing is designed in that manner. Okay. Here we have stack. Here we have those variables, and here we have pseudocode along with the graph. Okay. Let's call this graph once. What we did, S is equal to S plus I. We added that element 2 into the list. Correct? Because in order, we visited 2 first. So now 2 is green. We are still exploring it. From 2, now there is only one option, which is 0. So as per this law, columns of A. Okay, for each j in columns of A, ij is equal to 1. When ij is equal to 1, when it will be 1? Only when there is a age from I to j. That means from 2 to something. That age will be there from 2 to something. Now, in this case, that something is only 0. So there is a age from 2 to 0. That is correct. And that j is not a key in P. That means J as in 0. 0 is not a key in P. Why that is important? Because that will tell us that 0 is not yet visited. It will be important later on. You will know why this not key is very important, because just having age is not sufficient. We should also know that it is already processed, whether it is suspended or not. Right now, it's not suspended, so we can continue. Okay, so what we did, P of J is equal to I. That same thing. Now 2 becomes parent of 0. Right? So P of 0 is equal to I, which is 2. This information is, whatever I was talking about, right? This is the line, this is the age we were talking about. We updated the dictionary with 0:2, because 0 is now parent of 2. That's it. That's the end of 2. Because now we found our next step. Our next step is 0. So now we'll start the entire DFS procedure again from 0. That is why our DFS, we call it again with A, that adjacency matrix, P with the dictionary, S with list, and a new starting point, which is J. J as in this case, it's 0. Okay. So that's what we will start again. Now that will build up our next procedure call on the right bottom corner. That additional entry will be made on the stack. Okay. So you have to observe all these things happening on various places on the same slide. So now with this, we again call this procedure with updated values. Updated values are here at the top. Is everybody with me?
Sir, if we replace that is equal to that initialization point, we also write a return of DFS of APSJ. That's also same doing, because we are updating that PNS before that calling statement. So if you return that one, that's also do that same one, and after execute.
Okay. Yeah, correct. You are talking about, I saw somebody submitted that code. In that case, it will be 3 lines of code.
Sir, can get it. What, sir?
I mean, this yellow highlighted line over here, you are splitting that line into 3 lines, right? That is what actually you are doing.
Why I need to split the 3?
Because P you will initialize separately, S you will initialize separately, and then you're calling this one, right? Return.
Yes, sir, but PNS are already initialized.
Yeah, they are updated. Okay. You are saying
they are updated
instead of this, you are calling return.
Yes, sir. Just I calling this one is enough.
No, it won't be enough actually, but because if you write the return statement with this DFS or APSJ, right?
Yes, sir.
Every iteration will be there, it will be okay. Only problem will arise at last point, because we have separate return statement with PNS.
Yes, sir.
The problem will arise because this return statement will not execute when when these conditions are not met.
Yes, sir.
So when the entire graph is computed, the whole thing is done, this if condition will not execute.
Yes, sir.
And you will never reach to that return statement.
Yes, sir. So that's problem we are handling with that last return statement.
Last return statement. Okay. So you are saying we'll have those, you will return both return statements.
Yes, sir. So actually I write that code like I replace that PNS with return of DFS of APSJ. That's I think.
Yeah, I think that should work.
Yes, sir. I think some of the person is also asking that what I think.
What you are asking, right?
Yes, sir. So
yeah, that should work. That should work.
Yes, sir. Thank you, sir.
Yeah. Okay, so let's continue. So far you understood the iteration, right? What is happening? We have just finished one iteration of the procedure. Okay. Now we'll
yes,
go...
press F11. It will show whole screen. Something I think missing above.
No, nothing.
Above I, is there any statement?
Above I, no, above I there is nothing.
Okay.
Above I there is nothing. There's just I, P, and S. That's all. Actually, you don't actually have to look at my screen. You can look at your peer deck also. When I change slide here, the slide changes on your end also. So you can look at either shared screen or peer deck. Either is fine. Okay. Only thing in on peer deck, my mouse pointer may not be visible, but rest slide will be safe.
Yes, sir.
Yeah. When I change slide, it changes there. Okay. So now we start again, but this time value of I is 0. Once again, same thing. I is supposed to be inserted into list. So list became 2, 0. Start the iteration again. Now we are looking for new J, right? J again for each J in columns of A. So now for I, which is 0, 0 to J has to be 1. So 0 to 1, 0 to 4, 0 to 5, 0 to 2. All options are there. But 2 we will not consider because of this not is key. So that J should not be part of dictionary. Now J is what? If we consider J is 2, 2 is already part of dictionary. So that is reason 2 should not be considered. And that's why I said this not is key is very important. That will tell us which are suspended ones. Okay, it is suspended because it is already there in dictionary. That means it is suspended or completed, either completed or suspended. So in short, we should not consider that node. So we should not consider 2 because it is already processed or maybe semi-processed, right? It is partially processed. So we are looking for different J. So the J can be either 1, 4, and 5. As per our logic, it will be 1, right? So that is the next step. At that if that age from 0 to 1. Now we found it. Let's add that age in the dictionary with that parent-child relation. So new entry got added in the dictionary, which is 1:0. Because of this P of J is equal to I. Now let's move to next procedure call. Again, same thing. Now with this updated value, now our I changes. I mean, this I changes, this which is this J. Now we got this 1, right? So we should do DFS procedure again, starting from 1. Suspend 0, start from 1 again. That is what we will do. Suspend 0, start from 1. Let's continue. Now we'll do it in a bit faster. Okay. Now same thing. 1 is added. Now please observe these 2 lists and a dictionary. Okay. Added 1 into the list. From 1 we found this 1, 3. So that 1, 3 also supposed to be added in the dictionary. So we added that. 3 became parent. 1 is it? 1 is a parent and 3 is a child. Okay, so remember this. The key is child and value is parent. Okay, right. So next is we found new one, which is 3. So we start over from 3. So when we start over from 3, your I became 3. We started again from 3. We are supposed to look for next stage, which is 3, 4. So we added, 3 was already added. Now we'll add 4 into it. Our J became 4. So I think there is small, okay, we haven't reached that point. Okay, sorry, my bad. So we found 3. 3 is added. 4 is the new one which we found. So we added 4. From 4, now this is the point where we will again stuck at this point, because IJ we will find out, but is not key, right? This part, this line particular is key, right? Not is key. That will not give any result, because this node 4 has 2 vertices, has 2 neighbors, but both neighbors are already visited and they are there in the dictionary. So we cannot consider 0 and 3. So this entire for each loop will execute, but this if condition will not succeed. Okay. And because it doesn't succeed, we'll have to go back. Okay. So what is happening is, because that one is not succeeding, we go back to our previous procedure call. So last time in law, all those last questions, what was happening? We were
It will return.
yes,
P and
yes,
S.
it will return. Last time, what was happening? We were completing this procedure calls only at the end, correct? As somebody was saying, keep going up the stairs, and when you reach at the top, start coming down. But in this case, that's not the point. In this, for this particular scenario, we can close 4 at this point. You remember that question, right? We made 4 red and moved ahead because there is nothing processed. No need to suspend 4 because there is nothing to process. So we can complete 4 and continue with 3 with that backtrack. So whenever there is a backtracking, we complete something. So we complete 4 and we backtrack. So 4 is completed. Now we'll start from 3 again on that same stack. So there will be this completed one will be removed and next one will be added. We will retain it for for easier purpose. We'll just move it ahead. So that red one we can ignore. Only yellow and green one are important now. So again 3, from 3 we started with 5. So now 3, 5 age. So we should add 5 in a list, and that reference of 3 and 5 into dictionary. So 5 is J is updated. Now 5, 3 is added, and 5 is also added in the list. Okay, so that's the procedure. Same thing will happen with 5 to 6. Dictionary updated, list updated, right? And that's the point where we again have reached a point where nothing can be processed further. So at 6, we close, we complete this call and backtrack. Backtrack to which one? Backtrack to 5, the one which is just below, right? A step back. So at 5, once again, nothing to process. You backtrack to 3 now. Remember, 4 was already closed. So open or the suspended next call is 3. So you came back to 3. From 3, you came back to 1. From 1, you came back to 0. From 0, you came back to 2. And that's the point. Everything is completed. And that's the end of our complete algorithm.
Sir, I have a doubt.
Yes, tell me.
So in between, I couldn't understand, like from where you said the 4 was red, right?
Yeah.
Sir, how the code will know that it has to go backtrack? Like what will happen in the code that the code will go to the backtrack to 3?
Okay.
That thing I couldn't understand.
Okay.
Can I try, sir?
Yeah, sure.
Actually, we are going through a matrix. So at 3, we go to 3, 0. We do not get any age. Then 3, 1, 2, 3, 4. 4, we get age. And we suddenly jump to 4th row. After 3, 4, we suddenly go to 4th row of the matrix, and we process that 4th row. And after 4th row, we go to 4, 0, 4, 1, 4, 2, 4, 3, 4, 4. And we end up, and then we return back. After completing this for loop, we return PS, and we return back.
That's what I couldn't understand, how
again.
it is returning back to 3. That's what I'm asking.
Okay.
That return statement at the last P, S.
The PS will give
Okay, Tarika.
Actually, this whole for each loop will be completed.
Yeah.
No, whole for each J.
Okay, Ritik, I mean, you did. I mean, you did well. I mean, what your explanation is absolutely correct. Let me put it in a different way for you, Tarika. Okay, listen to this. What is happening is for that I. What is the value of I at that point? 4, right?
Yes, sir, 4.
For 4, we are looking for J. For every node, we
Yes.
look for J. Correct. So for 4, this vertex 4, we are looking for J.
But all the J's are already visited, so we cannot take
so
it.
we cannot find new J.
Yes.
That is the point. That means this for each loop will not execute. I mean, the loop will execute, but the if condition will never be succeeded.
Yeah.
Either because of this IJ will not be 1, or this not each key will fail. I mean, because of AND operator, either of two conditions will fail. So if will fail, correct?
Yeah.
So what you will do, you will do return P comma S.
So we will get the dictionary and a list, whatever it is mentioned.
Correct. Whatever is the current values are, they will be
Yes.
returned. And
Yes.
where that return will happen? Return will happen to the previous suspended call.
Oh, okay. Previous
The
suspended
whatever
call.
was recently suspended, we will go back there, right?
Okay, okay.
So
So
the
it
most
was
recently
3.
suspended was 3.
Yes.
So we start again from 3.
Okay, sir, I got it.
So from 3, I mean from earlier when we were started from 3, we were looking for J, right? Again at 3.
Yes.
We found J, which is 4.
Okay.
But this time, again, we will start from 3. We will look for J. But this time, that J will not be 4 because 4 is now completed. So this time, that J will be 5.
Okay. So,
Because, yeah, because last time when that IJ, right, it was when 3, 4, our conditions were matched. We updated that and we called again. We never looked for 3, 5.
Yes.
But now 3, 4 will fail because of this not key, not its key. So 3, 4 will fail, but 3, 5 will succeed and will do the processing.
Yeah, or I will be 3. So that's why
I will be
wanted to
3
check.
and now J updated, new J will be 5.
Yes. Okay. Got it, sir.
Right?
Yes. Yeah.
Why how it went back to 3. This stack is important for that.
Okay. Okay. Got it,
And
sir.
sir,
Yeah.
one more point, I think there is a precautionary point.
Yeah.
When I first visit, let's say 3, we go to 3, 0, 3, 1, 3, 2, 3, 4, and so on.
Correct,
right?
correct.
We start from 3.
Yes, yes. So J
But
will always
on
go from
returning
0
back,
to the last element available.
yes, sir. Yes, sir.
Yeah.
But on returning back,
Yeah.
when we come to 4 to then again 3, we will not check 3, 1. Means that J will not take. That will start from 3, 4 only. After that, we will directly go to 3.
Yes. Your understanding is correct. It actually works that way. I did not mention it because it might confuse others, so I just skipped that part. But what you're saying is correct. It will be like that. Where
So
it
that-
left previously, it will start from there.
Okay.
J will not take 0, 1.
Yeah,
J will,
J will
directly
not again
5.
take 0, 1 because see, when we suspend something, right? It suspends entire thing. Whatever was happening at that point was suspended. So when we suspended this execution and call this DFS with updated value, the for each loop was also going on, right? We did not complete that, but still we stopped that execution and went somewhere else. So that for loop will continue where it left earlier. So if that for loop is supposed to do 5 iterations and it has completed only 3, when we come back, only remaining 2 will be completed. It will not start again from initial point. It will do only those new iterations, the pending ones. That's why we call it suspend. Okay, you suspend wherever you were and you go somewhere else. When you come back, you continue where you left.
Sir.
Yeah.
Sir, depending upon the starting node, the list will change, isn't it, sir?
Yes, depending on starting node, list will change. Definitely, even the dictionary will change. List and dictionaries will change because your output, the final DFS tree will also change, no? Depending on starting node.
DFS depend on starting vertex.
Yes, the final answer always depends on starting vertex.
And that ordering depend on the matrix, how we define matrix.
No, order
Because
also depends on the starting vertex. Of course, matrix is important because that's where the edges are coming from. But
yes, at starting you said that if we start from 0, then we have to first visit 1, not 2.
Correct.
That actually defined in matrix IJ.
Yeah. No. That is because IJ is correct, but that is again the starting node is important, right? You started from 0, so there is a choice between 1, 2. So who comes first? In iteration, when you start from J will always start from 0. So in between 1 and 2, 1 came first. So we went to 1. That is how that is how it works. So it will always be the case. 1 will always come before 2 in iteration. Whether that age is there or not, it depends on that value of A, this A of ij. Okay. So Tarika, your doubt is clear?
Yes, sir. Thank
Yeah,
you.
Okay, sure. Thanks. Anyone else have any doubt with this? If not, then we can move to 3.2. We have already exceeded time. We are at 8:10.
Yes, sir. Please move.
Yeah. So 8.1, we constructed list, we constructed dictionary. So from list, we know, okay, from list, we know the order. We went from 2, 0, 1, 3, 4, 5, 6. So order is known to us. Now the important part is how to construct that tree using this particular dictionary. Correct? We know the dictionary. We know now 2's parent is -1. That means 2 doesn't have a parent. 0's parent is 0 is a child, 2 is parent, 1 is child, 0 is parent, and so on. This information is available with us in the dictionary format. But if we want to present in graphically, we should have some process, right? To process this dictionary, and we should do something, right? So now let's look at how to translate this dictionary. I mean, it may not require a pseudocode, because using pseudocode you cannot draw a tree, but how to interpret this dictionary in a pictorial format, that is 3.2. So for that, there is no question as such for you guys to submit, but I'll just explain. So just same dictionary, just return it in a vertical manner so that it's easier to understand. And that's our original graph.
Sir,
Now,
but
yeah,
dictionary will not have that sequence, no, sir. It can be in whatever way it wants, sir.
yes, correct. It can be in any sequence. But anyways, the sequence is not important.
Pictorially, how can we represent, sir, that now?
For that
List
list
will
is
tell.
there.
We can. That is what I'm telling you.
Father and parent and child. Okay.
Yeah, from parent and child. The sequence is not important.
Okay.
You can jumble this up, but still 2 will be the key and value will be -1 associated with it, right?
So that is always the parent.
Yes. So the key with value -1 is always parent, correct? No matter what, whether it's the first, where that value is. If the value is -1, then associated key is our parent. So by default, 2 become parent.
-1 means no incoming edge.
Yes, no incoming edge. So no incoming edge has to be the only parent will have no incoming edge. So that is the highlighted one. 2 becomes parent. So from 2, now we have to look for 2 on the right hand side. Okay. From -1 we begin. From -1 we reach to 2. From 2 we have to now look for 2 on the right hand side. Right hand side as in right hand side of the colon. That's why I just written it in a vertical manner to make it easier. So now we got this 2 here. From 2 we got 0. Let's update the graph also parallelly. From 2 we got 0. Now we should look for 0 on the right hand side. From 0 we got 1. Now from 1 we got 3. From 3 now there are 2 options, 4 and 5, right? Now for this, I mean, anyway, we will be adding both edges, so that's not a problem. I mean, who's first, who's next, that's not important. 3 is the parent for both 4 and 5. If you want to know whether 4 is first or 5 is first, you should check that list. Who came first in that list? Whether 4 is first or 5 is first in that list will tell you what was the order. But in a tree, order is not important. So 3 will have 2 edges, which is 3 to 4 and 3 to 5. Both will be added. And then from 4, at this point, we will also look for who's there from 4. We should look for 4 on the right side. We did not find anything. So we just move ahead. So from 5, we found 6. And now from 6, nothing is there and all are covered. Then that's the place where we stop, and those 2 lines, right, which we removed earlier, they will be removed. And that's our final answer. Okay.
Yes, sir. Yes, sir.
Okay.
Every
Any
question
doubts?
I understood, sir.
So that is
No
DFS
doubt I
and
get, sir.
recursion. Okay, sure. So
Sir.
if you do not have any doubt with this, then we'll close this. Yes,
Sir,
Prashant.
from the dictionary, how can we draw the tree, sir? I mean, we have, as a human, we have to interpret it.
Yeah. At human level only, I'm saying. I'm not saying at computer level. I'm saying only at human level. That's why there is no pseudocode. But if I give you a dictionary, you can draw this on using pen and paper, right?
Yes, sir.
Yeah, that is important.
We might given a project to draw from turtle. Using turtle, draw this dictionary.
Yeah. You can actually using Python, you can draw it, but that's maybe, I mean, that's beyond our syllabus. So that's something you can do later on. Okay, so let me end this in session. What is this?
Sir, if it is done, can you please take my questions from activity 2?
Yes. Okay, it's not an open session, but fine. I mean, just one question.
Sir, it's related to tree. That's why I'm asking.
Yeah, I mean, there will be many questions related to tree, but okay, fine. Hold on. Okay. I mean, we have already exceeded time, so I will take just one question and then maybe we will stop.
Sir, one question
yeah,
will take time because it has many graphs, and I want to ask like question number 4.
Week 10, right?
No, 11.2, activity 11.2.
Okay, 11.2. I think I know which question you are asking.
Yeah, it's graph, sir. Sir, if you ask me to draw,
I know. This one, right? This one. 4th one.
Yes, sir, this one.
I know. Yeah, tell me. No need to explain. It will not take that much time as you are thinking. Yeah.
Sir, actually, that in that question.
Sir, can we do like whichever is wrong? Can we do like one by one why it is
tell
wrong?
you. No need to do that. You have confusion is with this question, right?
Sir, actually in this question they are telling left branch are visited first. So
yes.
I asked to that instructor. So they are telling that means we are going alphabetical order. So that's point of view we are seeing we are going to A to B, not A to D. So
yes, sir.
that's point of view. We are going A to B, then we didn't have a H between D and F. So that's point of view that option 3 and 4 are wrong. Other options are right. So that is a confusion in that question that left side are visited first. That's what is the meaning of that one. So we are thinking
left hand side as in visually whichever is left side that is visited first.
So that means we are looking that question because on that question D is left side to that vertex A, right?
No,
yes,
no, it's not like that. B is left. B is left. D is
right. How you are telling B is left?
I mean, just look at the image, no?
Sir, yeah, sir, but we are looking at the question, right?
No, B is left. That is correct.
Because no, not a question. We should look at the graph, the tree. We are talking about tree, not the graph. See, left branch. Trees have branches. Graph doesn't have branch. Graph doesn't have concept of left, right. Only tree has lefts and rights.
Okay.
Okay.
Yeah.
When we say there is a left branch, only tree has branches. Graph doesn't have branches.
Okay. This is a new thing.
Yeah, I mean, I understand. So it's all some small technicalities, but don't worry. I mean, I understand, Tarika, what your question is. I will tell you why those answers are right or why those are wrong.
A to B or A to D
Yes,
first?
sir. Can we discuss?
Yeah. So let me discuss. Okay. So first one is just tell me first one is right or wrong. First one is right. So leave it that aside. I believe you know why that is right. No.
So let's choose the wrong ones.
Wrong ones.
Yes.
So I will tell you why some option is wrong. Only one is wrong, right? 3 are correct, so one is wrong. Which one is wrong? Can somebody?
I think there is a edge
Second
between
one,
B
no?
and F that is wrong.
Second one is wrong, no?
That's the second one. Could you scroll?
Yeah, the second one is wrong. Okay, so this second one is wrong. Okay, Tarika?
Yeah.
I will tell you why the second one is wrong. No, sorry, this one is second. Okay, hold on. This is first, this is second. Okay. This is ADF. I think that's not there in the answer. ADF. Okay. Yeah, actually 5 options are there. So 2 are wrong.
Yes, sir.
I assume 4. Okay. So let's discuss this one, why this one is wrong. Then we'll discuss why the remaining one is wrong. Okay.
Okay.
What is happening? You went to A to B, B to C, C to E, then from C, G, H, right?
Yes, sir.
Yes, sir.
Correct. So now considering this, you went from C to G, G to H.
C
Now,
to G.
B to F is possible.
B, yeah. When we were at B, right? B to
Yes.
F is B to F is possible.
And E to F is also possible.
A to F is not possible. It's the other way around. So B to F is possible, right?
Yes, B to F is possible.
So if B to F was possible, why that edge was not added here?
Sir, and show me ADF. But it is connected.
ADF is possible. Yeah, ADF is connected. But what do you remember? When we backtrack, when we stuck.
But sir, one node will be added once only, right? So if it is connected to ADF, then why we are considering like it should come with B also?
No, that's what that is what you should do. Left processing first, right? That means what? You went from A to B.
Also, whatever is possible in the left, we have to consider those first.
Yeah.
And the rest we will put it in the right.
Yes.
Like,
so this is
whatever is possible.
Okay, I'll tell you. So this is your graph. Now consider it fresh, blank. You started constructing your DFS tree. You starting from A.
Yes.
From A you went to B.
Yes. Then C.
Correct? B to C. From C you went to E.
Okay.
Then at E you there is nothing further you can do. No, sorry. At E, okay. Even that is a mistake, right?
From E also we can go.
You cannot go to B, but from E you can go to F.
Yeah.
But you didn't. But you didn't, right?
Okay. Okay.
So that's the mistake. I mean, you weren't stuck, but still you backtracked to C and started new thing, which is GH, which is wrong. You should have added F right here itself after E.
Okay.
Understood, right?
Yes, sir. Yes, sir.
Similar logic apply for that another incorrect option. I don't remember. I mean, I have to see. They all look pretty same, but one more option is incorrect, and that also has similar problem. I think this one only. This one, the third one.
Yeah, DF.
DF. Again, F should come below E, right?
It should come left side. Yes.
Yes. That's the point.
Okay. We actually couldn't get it the left side thing. Like we should not see in that.
I understand. I understand.
Okay.
Now you got it, right?
Now got it, sir. Thank you.
Okay, sure.
Sir, can we perform DFS ignoring that assumption, sir? Then also we'll get correct answer, sir.
See, whenever you do DFS, right? DFS will give you what ultimately? A list and dictionary, correct?
Yes, sir.
Who asked? Yeah, Prashant. Okay. So, no, not Prashant. It's, yeah, Prashant. Yeah, sorry. So, Prashant, DFS, result of DFS is what? A list and a dictionary, correct?
Yes, sir.
List is fine, but ultimately what you do? At the end, what we did? Somehow we have to translate that dictionary or list into in a tree, correct?
Yes.
That is at human level. So at human level, you can draw only, I mean, when there are multiple nodes at same point, you can draw one on left and you can draw one on right, correct? On using pen and paper, you cannot do anything other than that. One goes on left, one goes on right, obviously, correct?
Yes, sir.
So considering that, you should have some mechanism to process it. So either you process left first, then you process right, or other way around. Either is fine, but you should have some standardized mechanism. For this question, we said, please process left first and then go to right. You cannot just jump from left to right, right to left. That's not possible. Because it's a DFS. You start from one point, keep going. When you stuck, then only you process something else. So we said you do left first, then you go to right.
Yes,
some assumption has to be there, right? Without then you cannot do any processing. Like same wise, from A, there are two options, B and D. Why we always choose B? Because B is alphabetically smaller than D. This is the assumption, right? That we should do alphabetical order. It's an assumption. That's what we have decided. Similarly, for this question, we said do left first, then do right. Otherwise, there are n number of possibilities. For this graph, I can draw n number of trees.
Yes, sir. Got it.
Sir, if it is not mentioned that alphabetical, we have to consider it alphabetical.
Yes, I mean that's part of the lecture, right? That's part of the lecture. Even sir said that is how we will do it, and that's what even all questions have followed. See, actually with pseudocode, it will naturally become alphabetical order, because when we iterate over that columns of J, right? You remember that pseudocode, right? This one. When we say for each J in columns of I, J will always start from 0. So it will from 0, 1, 2, 3, 4, 5. So it will be in that order, no matter what you do.
Okay.
Okay. Yeah. So this for each J in columns will actually
pseudocode, it will be in order also. And
sorry?
also if it is pseudocode, then definitely it will be in order. But if only graph given, then also we have to consider the order.
Yes, you have to, right? Otherwise, you cannot find correct answer. Some order has to be, some, as I said, some assumption you have to make, then only you will get the answer. Okay?
Yes, sir, we get it.
Okay, sure. Actually, this assumption is not required. For this kind of assumption, there is another algorithm. But that, I mean, that might be too complicated for you. That's why we haven't added it here. That you will study later. So for time being, let's go with assumption, but computer doesn't assume anything. Okay. I mean, computer follows instructions. Computer cannot do any assumption. So there is an algorithm to handle such scenarios. So you will study that separately. Okay. Something, I mean, I'll just, if you want, I will just give you names. Later on, you can look for this on Google if you are interested. It is a bit complicated as compared to this, but it won't be. We will not ask questions to you on that. But something called like there are some traversal techniques. This is traversal, right? Deciding which one to visit next. So that's something called as traversal techniques. There is something called as in order, post order, and pre-order. So we have to choose one of those traversal techniques along with this to decide which one to visit next. So that's a different set of algorithms. So I mean, that's something no need to discuss now. I mean, it's out of syllabus at this point. Okay. So we will go with this assumption either in a incrementing order or in a alphabetical order. That's what we will do in CT. Okay. Fine with everyone? Sorry?
Yes, sir.
All right. So with that, we'll close the session. It's already 8:30.
Okay, thank you, sir.
Please check your calendar there for upcoming sessions. I think this is the last session of the standard sessions, right?
Standard means?
The standard session is this open session, revision session of each week and so on. Now we only have these revision sessions, right? 11 weeks of content is
on 1st of December.
Yeah, on 1st of December, there is a revision session for week 9 to 10. That is those graph weeks, 9 and 10. On 2nd December, dedicated session for recursion, as I mentioned, which I will do. That 1st December, I don't know, somebody else will do. 2nd December, I will do. Then there is a revision session for previous weeks also. For, lists, dictionaries, procedures, and nested iteration, binning, and all those concepts. Which
revision, no.
Yeah, revision. So that is 1st December, 2nd December, and 5th of December. 3 revision sessions are there.
And 9 as well, sir.
9 is a mock. I think mock will happen on either 7th or 8th. And because of that, there will be a mock question solving on 9th.
How many mocks?
Only one mock. Why you require multiple mocks?
Because we have 10 days time.
Yeah, but you are also writing one exam, no? For one exam, one mock. Okay.
No, sir. Actually, practice is very more important, sir.
Yeah, I think
practice assignment is there.
For practice.
See, during these revision sessions, there will be practice. Okay, so don't miss these revision sessions. They will help you immensely.
And sir, in the exam, it will be objective type. You will not ask us to write the code for the answer, right?
Yes, correct.
So the main problem is that actually the keyboard are not properly working.
I told you, right? I would like to ask questions to. I would love to ask those questions where student write code, but unfortunately, as I said, the exam partner doesn't support that. So you come to Python, then I will ask you questions on that. I will ask you to write code in Python. Just
yes, sir, in Python we will write.
TSS not involved there.
Not now. Sorry.
Tata consultancy service will not involve there.
No, they will be involved only for objective type questions. For programming questions, we have a different mechanism. We do those exams in a remote proctored manner. You will do those exams sitting at your home.
Yes, sir. One of our senior told us that it will be all proctored. A group of 5 students will be considered and take as a group by group exam will be taken.
Yeah, right, correct. So that's something we can discuss later when you start Python. Anyway, I will be there in Python, so we can discuss that later.
So will you be there for as a coordinator or not, sir?
Yeah. I will be there. I will be there for Python. Okay. All right. So let's close. Thanks everybody for joining.
Thank you, sir.
Thank you so much.
Bye.
Thank you, sir.